right, here we go with a review of Chapter 7 for Algebra 1, which in a general course would be the chapter on systems of equations, solving by graphing, substitution, and elimination. So we'll start off here with 4 graphing problems. So in each of these problems where we've got a set of equations, our answer is going to be a point, x comma y. It's really easy to see how that works when we're graphing, because when we graph, we get points. But even when we're not graphing, when we're doing it by hand, we'll still get an x value and a y value, so we can still write it as a point, x comma y. So remember that when we're writing points, we use the alphabet. It's in alphabetical order, x and then y. If we were using other letters, it would still be in alphabetical order, so a comma b or c comma d, things like that. So to graph, we start with the number out to the side when we're in slope-intercept form, which is y equals mx plus b. We start with b, so we start with this -2. It's our y-intercept, so it goes on the y-axis. And then we look at the number in front of x, which is our slope. We use our slope to go up and over. So the 1 is telling me to go up 1, and the 2 is telling me to go over 2. And we do both of those in the positive direction because this is a positive 1/2. Or we could do them both in the negative direction because 2 negatives make a positive. And we can keep going either direction, making more points. Now, this isn't normally required when we graph a line to make a whole bunch of points, but when we're solving a system by graphing, the more points we have on this first line, the easier it will be to tell where the lines meet. It also makes it easier to draw a straight line, so there's that advantage as well. The second line here, we're going to start at 4. And our slope isn't a fraction, so we make it a fraction by putting it over 1. It's telling me to go up 2 and write 1, but I don't have room to do that, and that's not getting me any closer to the other line. So I need to instead go negative both directions, down 2 and left 1. It's a common mistake to when you don't have room to go down 2 and then still run to the right, but that would create a negative slope, and this is a positive 2, so it's a positive slope. So you got to watch out for that. If I keep making points back, again, the more points you make, the easier it'll be to tell where they meet. If we just draw our line willy-nilly, it will be hard to tell where they meet. Or even if you use a ruler, it can be hard to tell. So I encourage you to make a lot of points. We can see now that they meet at the point -4 comma -4. And so this is our answer. If you've got a teacher like me who's really big on showing work, the graph here is your work, your answer is the point. So we have shown our work and gotten our answer. On number 2, we're going to start at 4 on the y-axis. Our slope is up 8 over 1. There's definitely not room for that, so let's go down 8 and to the left 1. That is quite a steep line. So it's got to intersect at one of these 2 points. Y equals -4 is a horizontal line that goes through -4. You can think of it like it has a 0x, so it has a slope of 0, which means we won't go up and over at all. So this is a horizontal line, like so. And so it intersects here at the point -1 comma -4. On this next one, we have to start at 4. Wow, lots of starting at 4 here. And then what's in front of x is secretly a 1, so we'll make that be 1 over 1. So we're going up and over. And then the chances of that being where we meet is pretty slim, so let's go the other direction as well. And it may seem like overboard to make all these points, but it's going to make our line nice and straight, and one of those points is where we will end up intersecting. Then we'll do the -3. We'll go down 4, right 3. Oh no, there's not room. When it's a negative slope, because that hasn't happened to us yet, you go down and over, or up and to the left. So this would be a negative positive, this would be a positive negative, because one of them has to be negative, but we don't want both to be negative. So since I don't have room to go down 4 over 3, I need to go up 4 left 3, which, gives me my answer. These intersect at -3, 1. You don't have to circle the point. I'm just trying to make it more obvious what our answer is. On number 4, these are not in slope-intercept form, so our first step should be to solve, and both of these have the same first step where we subtract the x over. So our first equation ends up being y equals -2x plus 3, and that's all that we have to do because y is now by itself. On the second one, we're going to subtract 2x. But this time, make sure you don't forget about that negative because lots of people do. This time, we need to divide everything by -1. So make sure you divide everything, not just part of it, by -1. That ends up being positive 2x and -1. So this first equation starts at 3 and goes up 2 and right 1. No, it doesn't. It goes down 2 and right 1. That's a -2 over 1. That was a close one. And then this next one, you start at -1. And you go up 2 and right 1. And our answer is 1, 1. Let's do a couple more problems like that. These also are going to require us that we do some solving here. But there will be similar steps probably. So here on 5, we need to subtract x. So we have -y equals -x minus 3. We're going to divide everything by a -1 to move the negative from in front of y. Then we're going to subtract 7x from both sides. And get -y equals -7x plus 3. Divide everything by a -1. So y equals positive 7x minus 3. So this first one starts at 3 and goes up 1, right 1. I shouldn't have to go super far because of how steep the other one is, but you're welcome to put as many dots as you want to. This starts at -3 and then goes up 7 and right 1. So from here, up 7, right 1 is here. And so that intersects at 1, 4. And this last one in this section, we have a vertical line of x equals 4 that we can go ahead and graph. Remember, x equals is vertical, y equals is horizontal, because when it says x equals 4, it means that no matter what our y value is, all of these points should have an x value of 4. For the other one, we have to solve, so we have to subtract the 7x over and then divide everything by -4. So y equals positive 7/4 x, because the negatives cancel, but the fraction can't be simplified, so we'll leave it alone. And 16 divided by -4 is -4. So we're going to start at -4 and go up 7 and right 4, which puts me right here on my line. So that's 4, 3. All of these problems, by the way, we could check to see if we did it right by plugging them back into our original equations. So for instance here, we already know that it fits for x equals 4 because our x value is 4. But we could also do 7 times 4 minus 4 times 3 equals 16 and see if that's true. 28 minus 12 is 16. So it works for both of our equations, which means that we picked the right point. If you were to do it and one or both gave you incorrect statements, like it told you that 24 equaled 16 or something like that, you would know that you messed up somehow, and it would be a good idea to go back and try it again. So the next way that we solve, this is called substitution, and the idea is that we want to know what one of our variables equals, and then we will use that to plug it into the other equation and it'll let us solve and get one of our variables. So if I start with the first one, number 7, I know right now that y equals 2x plus 7, and I just want to plug that in for the other equation. I want to plug it in where y is. So that means I'm going to rewrite this as negative 4x plus 2, and then where y is, I'm going to write 2x plus 7, and then it equals 14. Now this is kind of a long situation we've got here, but because now we just have x's, we can solve this and figure out what x is. So I can distribute 2 times 2 gives me 4x plus 14 equals 14. And that means that a special thing is happening here. My variables cancel out and I get 14 equals 14. So what that means is that there are a lot of numbers that work for this. In fact, there are infinitely many solutions to this problem. That doesn't mean that anything can be an answer. There still are certain things that have to hold true. It has to be two things that when you plug them into both, that they both work. But there ends up being a whole lot of answers, not just one. So that's one of the types of special cases that we can get, is that there are infinitely many solutions. Number 8. Okay, number 8, same situation. We already have an equation where we know what y equals, and so we're going to plug it in to the y for the other equation. So we'll write 3x plus 2, and where y is, I'm going to write 3x plus 5, and it equals 1. So I just took where the y was, and I put the 3x plus 5 in parentheses. So I need to distribute. So 2 times 3 is 6, and we put an x with it. 2 times 5 is 10. 3x plus 6x is 9x. Since they're on the same side of the equation, we just add them like normal. We don't subtract them. That would be if we were trying to move it to the other side for some reason. Then I do subtract 10. Again, I'm moving it to the other side, so that's why I'm subtracting instead of just adding it. 1 minus 10 is negative 9. I'm going to divide both sides by 9 and get x equals negative 1. So now that I know what x is, I have to plug it back in to find y. You can do that either of these two places, but it will be faster if we do it in the first one where we're already solved for y. So I plug in the negative 1. 3 times negative 1 gives me negative 3. Plus 5 gives me 2. Make sure you multiply and then add because of order of operations. And so our answer is x comma y, negative 1 comma 2. Now in these next few problems, there is not a variable already by itself. So we're going to have to start off by getting a variable alone. So for instance, it doesn't really matter which variable you solve for, but like if I look at 9, this y, since it doesn't have a number in front, that's going to be the easiest thing to solve for, and it will be the least likely to give me fractions. In fact, there's no way for this to give me a fraction when I solve because there's nothing to divide by. Whereas if I picked something else, like the x, the y in the second equation, I might get some fractions. I might not, but I might. So if I decide to solve for this y, I just need to add the x over. This is like how we solve for y whenever we're getting y equals mx plus b, like we did on the first section. So I add the x over and get x plus 13. And then I take this and I plug it in where the y is. So 8x plus 4 times x plus 13 equals negative 20. I need to distribute. 4 times 13 is 52. Make sure you don't forget to distribute all the way. I'm going to subtract 52 from both sides. I didn't have to do that right there. I could have waited a step. I also need to do 8x plus 4x and get 12x. And that equals negative 72. And then I divide both sides by 12. So x equals negative 6. And then I need to take this and plug it back in. Again, this place right here where we already know what y is supposed to equal will get us there the fastest. Y equals negative 6 plus 13 means that y equals 7. So my answer is negative 6 comma 7. If you're feeling confident, this would be a good place to start trying these on your own. So you might try pausing the video, seeing how far you can get, and then replaying it. If you get all the way to an answer, you could skip ahead to the answer. And then if you don't get it right, rewind and figure out where you went wrong. But it's important at some point along the way here for you to start trying these without help so that you know if you've really got the hang of it. On 10, the same kind of situation is happening. This y would be the easiest thing to solve for. We could solve for this x instead, and that would also be pretty easy, but it would have an added step because of that minus sign that we'd have to divide by a negative. So I'd rather just solve for the y by adding x to both sides. Y equals x minus 1, or negative 1 plus x, if you wanted to leave it that way instead. So this is 5x minus 4 times y, which is x minus 1, equals negative 2. These problems should end up feeling pretty repetitive once you have the hang of them, because we're going to do really similar steps each time. So we distribute the negative 4 and have x plus 4 equals negative 2. We subtract 4 to finish this off, and we get x equals negative 6. Then we take this and plug it back in. Negative 6 minus 1 gives us negative 7. Wow, these two ended up with really similar answers. Whoa. Coincidence? Actually, yeah, probably. All right, 11 and 12. So same situation, that you should try to do these on your own if you are feeling pretty confident about them. On 11, this is the first one where instead of solving for y in one of my equations, solving for x would be a much better idea. This x right here doesn't have a number in front, so I can just add the 3y over. We are not required to solve for y. That's only when we're graphing that we can't make do if we solve for x. We have to solve for y. So here it's fine to solve for x and get 3y plus 7. Now when we do that, we have to be careful. We got to make sure to plug that into the x, not the y. And so that means our equation is just going to have y's in it instead of just having x's in it, like on the last 4 problems. So this is 6y. 2 times 7 is 14. Minus 4y equals 8. So 6y minus 4y is 2y. We're going to subtract 14. 2y equals negative 6. Divide both sides by 2. So y equals negative 3. So again, we want to make sure to plug this into the right place. And this will be the easiest place to do it. If you plug it into one of these first 2 equations, you can still come up with the answer. It'll just take you extra steps, which is fine. So we want to plug the negative 3 here. 3 times negative 3 is negative 9. Negative 9 plus 7 gives us negative 2. So I get negative 2 comma negative 3. Moving on to number 12, the last one in this section, we need to look and see what the easiest thing to solve for would be. The x, or the x and y in the second equation, all of those would require we divide by the number in front to solve for them, and so that would give us fractions, which will just make this harder than it has to be. So instead, let's go ahead and solve for the easy thing, which is the y in the first equation. So I'm going to add 3x to both sides. which gives me y equals 3x plus 8. And then I'll put that in where the y is in the other equation. So negative 4x plus 3 times 3x plus 8 equals 4. I need to distribute. So negative 4x plus 9x plus 24 equals 4. And then negative 4x plus 9x, those are like terms that I can add together. And then I need to subtract the 24 over to the other side. And divide both sides by 5. I get x equals negative 4. That's half of my answer. I need to go back and plug that in and find y. So y equals 3 times negative 4 plus 8. Multiply first, so negative 12 plus 8, which is negative 4. So my answer is negative 4 comma negative 4. That's substitution. The other method we have is called elimination, or some books call it linear combinations. The idea here is we want to combine our two equations using addition. So we have to add the x's together, add the y's together, add the right-hand sides together, because that's our like terms in each of those columns. But we want to do that in such a way that one of our variables eliminates, because it has the same number in front but different signs. So this first one actually is already set up for us to be able to do that. If I do 2x plus negative 2x, those add together to get 0x. So they eliminate, or in other words, they cancel out. But in order to do that, we need to continue adding the rest of the equations together. So negative 7y plus negative 1y gives us negative 8y. And negative 16 plus negative 16 is negative 32. Make sure you're careful here and you do actually add these together. When we add numbers together, we do pay close attention to whether they're positive or negative so that we come up with the right solution. So negative 16 plus negative 16 does not give us 0. It gives us negative 32, because adding two negatives gives us a more negative number. Now we just need to divide both sides by negative 8, so that y equals 4. And then once we know what one of them is, we have to go back and plug that into one of these equations up here. It doesn't matter which one we pick. I personally just like to always pick the first one unless I have a really good reason not to, like if the other equation has smaller numbers or something like that. So I put the 4 where y is, and with this method you have to do a little bit more work to find the second part. The first part comes faster. The second part of your answer takes more effort. So we have to multiply to get negative 28. We have to add. And that gives us 12. We divide by 2 and get x equals 6. So our answer is 6 comma 4. And the rest of these are going to vary in how much we have to do at the beginning to set this up. Get harder, actually. They don't vary. They are going to get progressively harder. So for 14, for instance, if we try to add them together right now, nothing cancels, but we're really close to being able to get them to cancel. In fact, if instead of adding, if we were allowed to subtract these numbers, they would cancel. So to make that happen, what we want to do is pretend like we are multiplying, or not pretend, we are actually multiplying by a negative 1 on this first equation, so that we get positive 2x minus 4y and negative 22. And what that does is now you can pretend that first equation isn't really there anymore. We can add the second equation with the equation we just came up with, and when we do that, our y's will cancel, so that we get 9x equals negative 9. We divide both sides by 9 and get x equals negative 1. We take that and we plug that back into any of these three equations. We can use the one I marked out. We can use the one that we created ourselves. It does not matter. We can also use the middle one. So if I just continue using the first equation to plug into, I end up with -2 times -1 plus 4y equals 22. So I do this multiplication right here. I subtract 2 from both sides, and I get 4y equals 20. So I divide both sides by 4 and get y equals 5. So my answer is -1, 5. And the rest of these are just there's gonna be more to it that we have to do. So on 15, we can't add or subtract and get something to cancel. So we're gonna have to actually multiply one or both equations by a number so that we end up with a number in common that will cause us to cancel out. What I mean by that is if I look at the x's, one has a 5x, the other one has a -1. Wouldn't it be nice instead of -1 if that was -5? How do we accomplish that? How do we make there be a 5 in front of x? We would multiply the whole equation by 5. Alternatively, we could multiply the first equation by 2 so that we'd have -2y and +2y, and that would accomplish the same thing. And it doesn't matter which way you do it, as long as you don't make any mistakes, you should get the same answer. Just remember to multiply everything in the equation. That's a common mistake that gets made. And then either ignore the middle equation or write the first equation back down underneath to make it easier to add these together. We get 10y minus y, which is 9y, and 25 plus 2, which is 27. We'll divide both sides by 9 and get y equals 3. And then we'll take that and we'll plug that back into any of these 3 equations up here at the top. So I like the first one. And we don't even have to multiply because there was not a coefficient for y. Well, there's a coefficient of -1, but now we divide by 5 and get x equals 1. So our answer is 1, 3. And if you have not already at this point paused to try to do this on your own, this would be a good place to start to see if you've got the hang of it. Pause the video, try it on your own, and then either skip ahead to the answer on the video or just go ahead and play it out so you can see how you did. So on this one, there are 2 ways that you might try to eliminate. There's actually more than 2, but there's 2 main ways. One is if you see that I could turn this -3 into a -6, which would make these add together and cancel. You also instead could multiply both equations by something to eliminate y's. Your goal would be to try to get 10 in front of both y's, so we'd multiply the first one by 5 and the second one by 2. It would be easier to just multiply the first one by 2 to get a -6x, but it really just is whichever one you are more likely to see, that's what you should do. So our x's cancel. 5y minus 4y is y. -11 plus 4 is -7. So y equals -7, and now we will plug that in to our other equation. So -2 times -7 is plus 14. We subtract 14 from both sides and divide both sides by -3. And x equals 4. So our answer to this one is 4, -7. On these last 2, they are set up so that it makes us multiply both equations by something, unless you are willing to figure out a decimal, which is not necessarily that hard to figure out. It's just most of us would probably prefer to avoid fractions and decimals. So we would find it easier just to multiply both equations by whole numbers instead. On x, if we decide to eliminate x, or y actually, in both cases, the number that we could get to easily is 10. But depending on which one we decide to eliminate, it's going to change what we multiply by. Also, notice that in each of these problems that we did, one of our letters was negative and one was positive. If that hadn't been the case, like if this was a positive 5x instead of a negative 5x, we'd need to multiply one of the equations by a negative number in order to change it so that they were opposite signs, kind of like what we had to do on 14, where we had to multiply by a -1. So it doesn't matter which of these we decide to eliminate. If we decide that we want to do x, then we would multiply the first equation by 2, because that's how we would make -10. Multiply the second equation by 5, because that's how we'd get +10. So this would be -10x minus 4y equals -36. 5 times 2x is 10x. 5 times 5y is 25y. And 5 times -18 is -90. And then we add our equations together. So the x's cancel. -4y plus 25y is 21y. And -36 plus -90 is -126. Believe it or not, 21 goes in 6 times. -6 times. And then we go back and plug it in. There are 4 places that we can plug in this -6 and get our answer. And it doesn't matter which one you pick. I do encourage you to pick one of the first ones because it has smaller numbers and that makes our math a little bit easier. But it's really up to you which one you want to pick. I'm going to pick the first one because I always pick the first one. So -2 times -6 gives us a +12. I'm going to subtract 12 from both sides. And get -30. I'm going to divide by -5. And get x is +6. So this is 6, -6 for my answer. 18. So this is a similar thing as 17. We're actually, in both cases, we would try to get 30. But I didn't point this out on 17. If you try to get 30 for x, you do 5 and 6. If we tried to get 30 for y, though, we'd have to do the opposite and times the first one by 6 and the second one by 5. So make sure you're paying attention to which one you're trying to eliminate. You wouldn't want to accidentally multiply them both by 5 or multiply them both by 6. And this is kind of an unusual case, and I'm sad that it happened on both of these problems I picked out. I would have liked a more interesting situation to happen, but it's too late now. If I multiply to get rid of x, I'm going to do 5 and 6. Again, it matters that one is negative and one is positive. If that wasn't the case, I'd have to also multiply by a negative on one of these to change it, but it's already good to go. So my x's cancel, I get 11y equals -44, which 11 is one of the nicest numbers to divide into things. So we get y equals -4. And then we plug that back in. So -6x plus 20 equals -4. So I'm going to subtract 20 from both sides and get -6x equals -24. So divide both sides by -6 and get +4. All right, so that's the 3 methods, and that's 6 problems of each, so lots of practice. Hopefully was able to happen here. Now, this last section, and typically whenever we have this sort of problem, sets of problems, typically we, as teachers, ask you to solve some where we don't tell you what kind to use, that we expect you to make some sort of a decision as far as which way would be the best method. So I've picked out here, when I made this, I purposefully made it so that there is one that you should think substitution is easiest on. There's one that you should think graphing is easiest on. There's one that you should think elimination is easiest on. And then there's one where at least two of the methods should be easiest. And hopefully if I'm paying enough attention, I'll make it go a step further on the test and have there be one where any of the three methods is equally easy. So on the first one, what clues you in as to the method is, for one thing, this is not arranged nice and pretty like what we're used to. Our x's are not on the same side and as each other. They're not lined up. And more importantly than that, though, we already know that x equals 20y plus 19, which means this is set up for us to solve by substitution. You are welcome to solve this by elimination. You would need to move things around so that you had the x's, y's, and the numbers lined up, and then you'd go through the process of elimination. But to substitute, we just take what x equals and we put it in for the x in the other equation. So 10y plus 4 equals 6 times 20y plus 19. So 10y plus 4 equals 6 times 20y is 120y, and then 6 times 19 is 114. We need to get the y's on the same side and the numbers on the other side. So it doesn't matter which way you go. I can subtract 120y, or I could subtract 10y. But whichever way I move the letters, I need to move the number the opposite way. And this may have looked bad at first when we got that really weird number of 114, but when we see this through, we get something that works out pretty nicely here, because 110 divided by 110 with a negative is -1. We're going to take that and plug that back in to either equation, but the easier one is the first one. And we get x equals -20 plus 19, so x is also -1. So our answer is -1, -1. If we read the instructions, it says a graph is provided in case you decide to solve by graphing. So we don't need to use the graph because we didn't choose to use graphing. On 20, I am going to choose to graph because these are both in slope-intercept form. There's a fraction which would make substitution a little less pleasant than another method. And honestly, if it's in slope-intercept form and we're decent at graphing, I would imagine that most of us actually would prefer graphing because it's less work. Now, if the equations aren't set up that way or it doesn't work out to be a nice point, then graphing's not the best way to go. The first one starts at 2 and has a positive slope of 1/2. Make sure you go both directions, making points. And -2 on the second one, and we're going to go down 1 and right 2, or up 1 and left 2. And so we can see that our graph meets at -4, 0. Make sure you remember how points work. We went left 4 and not up or down, so that's why it's -4, 0. 21 here is the one I would say elimination or substitution would be about the same amount of work, because we could solve this for x and then plug it into the other equation. I happen to personally like elimination best. That's just my personal preference, and you're allowed to disagree with me and have a different favorite. It's up to you. Either in front of x, we should try to get a -4, or in front, or sorry, just 4 in general, but we'd have to make it negative on the first equation. Or if we decided to do y, we'd want 12, and so we'd multiply the second equation by a 2. I'll go ahead and do x, so that requires a -4 since we want these to cancel out, not add together. So that's -4x plus 48y equals -60. So 54y equals -54. We divide by 54, and y equals -1. So then I plug that back in. X plus 12 equals 15, so I subtract 12 and get x equals 3. 3 comma negative 1 would be my answer. This last one I definitely would use elimination, because anything else you'll get fractions that are unpleasant and would make it very difficult for us to be able to actually come up with the right answer. We either in front of x want to get 12s, because 4 and 3 make 12, or in front of y we could try to get 30. I personally, I know I've been eliminating x a lot, but really the way I decide is which one gives me a smaller set of numbers to multiply by, because smaller numbers mean less errors, hopefully. We don't need to multiply by a negative, because one is going to be positive and one is going to be negative naturally because of how they start. So 18y minus 20y is negative 2y. 24 minus 28 is negative 4. So I'm going to divide by negative 2 and get y equals 2. And then plug that back in again. Doesn't matter where, anywhere with x and y will do it. So 4x plus 12 equals 8. So subtract 12. Get 4x equals negative 4. Divide by 4 and x equals negative 1. So my answer is negative 1 comma 2. Hopefully you haven't stopped listening even though I'm done with the review, so that you can hear me say on every single one of these problems we could know if we are correct by taking what we got and plugging it back in and saying 4 times negative 1 plus 6 times 2, does that equal 8? And if it does, then we go on and do the second equation, plugging in x and y where x and y are, and see if that's true. If both of these are true, we picked the right, or not picked, we found the right answer. If either of them are false, we've messed up somewhere and need to go back and try to figure out where and try it again. So in theory, if this is what an entire quiz or test is over for you, you should be able to know at the end if you got a 100% or not, because you should be able to check all your answers. I would recommend that if you decide to do that, you go through the whole thing once without checking and then go back and check. That way, if you get stuck on a problem, you won't leave half your test blank because you got stuck there. So this has been Solving Systems of Equations. Happy studying.